Hello, good afternoon, good evening, good morning, good night. Depends on where you are. Well, based on the popular demand, there's a person that asked for one of my YouTuber that asked for explanation on the calculation regarding radioactivity. So for that reason, I want to do this video. So let's start straight ahead. If you're just coming across this YouTube, this is the Pioneer Maths and Physics class YouTube. So if you are new here, just click the subscribe button and at the same time click the notification bell so that you can get first-hand information and well updated anytime I drop the video. So today we'll be looking at half-life reading, but we'll start with radioactivity. That is where we start from. The real topic here is radioactivity. So let's see how it goes. Radioactivity. What's the definition of this topic? The definition goes thus: that radioactivity can be defined as the spontaneous disintegration of radioactive elements to give off radiations. So simply put, these radiations, they are just three in number. Radiations can be summarized as three. We have three radiations here, three radiations, even though this is not the aim of discussion today. We have alpha rays or radiation. We have the second one is beta ray, the beta ray, and the last one is gamma rays. Which is this. Now, just like I defined it, I said it's spontaneous disintegration. The disintegration here can also be called decay. So that is where the issue of half-life comes in. So let me go straight to half-life. So what is half-life? Half-life. The way the name sounds, it means life is divided into two. That is the meaning. So he is talking about the life being half. So it is defined as the time it takes a radioactive element to disintegrate or decay into half of its original number of atoms. So that is why it is denoted with T to really signify that it is time we are talking about. And what is the unit? Units differ. It can be in seconds, it can be in minutes, it can be in hour, it can be in days, it can be in week, can be measured in months, can be measured in years. It depends. Some elements they disintegrate into half of their original number in seconds, maybe 10 seconds. Some in 10 minutes. Some will take like 20 hours. Some will take like 20 days. It depends on the element. Now, what are the parameters to calculate anything in half-life? So we take note of these parameters. The parameters here, they are a bit many. When we say n naught, that means original number of atom. Number of atom or mass of atom. While nr is the remaining number of atoms or mass of atom. Nd here means decayed number, decayed number of atoms or mass of atom. Then we talk about R. R is ratio of decay or disintegration. Ratio of disintegration. See that? So that's one is going to be R equals the original number and the number remaining. Now, capital letter T here is half-life, the time it takes half of the original number to decay. While T is total time taken. Total time taken. That is, how many half-life do we have there? So here is talking about the total time taken. Maybe the half-life is 2 hours. We now have 10 hours. You should know that it's total time taken at that time. So here we have N. That is number of half-life. Half-life. So now let's go to the formula. The first formula we are talking about here is easy, and that is we must note this. This N here is equal to small letter t over capital letter T. Then from here, we have different formula here so that we can be happy. So look at the formula. The formulas. We have one. The first formula here is the number remaining. Okay, the number remaining plus number decayed is equal to total number. We must note that. While second formula here that can assist us is that number remaining is always what? Is always a fraction. Oh, I didn't mention fraction there. Let me put that there. Half is fraction of the original number that disintegrates, that remain. It depends. If you say FRA, fraction of the original number that what? That remain. Why if you put FDA, it's a fraction of the original number that decay or disintegrates. Decays. So here we have 1 all over 2 raised to power n times original number. I can rewrite this thing here to say that it means n naught is equal to 2 raised to power n times n r. So we can decide to say we have equation 1, equation 2. These two, they mean the same thing. Is that okay? I believe so. Then from there, we can decide to say that, okay, if we have that n naught over nr is equal to 2 raised to power n. And don't forget here, our r is what? Our r here is n naught over nr. That is the ratio of disintegration. That is r here is equal to 2 raised to power n. Equation 2, let me say 2a here. Here is 2b. Equation 2c. That is on that. Now let's go to the other one, third formula. Third formula. That one, I have to prove it, but there's no time to be proving anything here. But let me give us the formula. It's talking about decay constant, which is what? Lambda. And decay constant, where do we get this? Is always what? Is obtained. When do we use it? When the time is not half-life or multiple of half-life. Multiple of half-life. If it is half-life, let's say half-life t, capital letter T is 20 seconds. They now give us 50 seconds. You know it's no more multiple again. It should be like times 2, times 3, times 4 of 20 seconds. So in that case, the formula we are using then will be n r, number remaining, is equal to n naught exponential minus lambda t. See that? So this is the equation 3a here. Now from there, we now say that we have our nr over n naught is equal to exponential lambda minus lambda t. So from what we see there, this r equals exponential minus lambda t. Then let's go down. We can easily see that this r here, or 1 over r, sorry, find the reciprocal. If you're using this, it becomes 1 over exponential lambda t cap positive now. That is, we say that the exponential lambda small n that small t is equal to big R. the rate of disintegration. So from here, if you use our knowledge of mathematics, we know this to be log to base e of exponential t equals log to log of base e. Then here we have lambda small letter t is equal to log e base r, and from there we'll say that this means that what we are saying that t small letter t is equal to, or lambda here is equal to log e base r base t base e equals all over t. So we can say this one here, or we say lambda, or we say that t is equal to log r base e over what? Over lambda. Now, that's not the end of the whole story. So now, if nr equals half n naught, therefore, what will happen? T becomes automatically the half-life. That is, if it is half of it that is remaining. So we can now say that n r over n naught is equal to half. That is to say, we have n naught over nr equals to, if you find the reciprocal, that is here, what we are saying is that r equals what? Equals 2. So from there, we pick this formula here, this formula that we got here as 3b to become what? Let's be sure that's 3b. We have 3a up there. So 3b now will now become what? Our capsule letter t will come to t, and we have log r log 2 now base e over lambda. That's equation 3c. So from here, we want to combine the two together to say that equation 3c divided by equation 3b divided by equation 3c. So here we'll be having t over t equals log r base e over lambda divided by log r log 2 base e over lambda, which means that t over t here is equal to log r base e over lambda times lambda over log 2 base e. This cancel this, and we have the time taken over the half-life equals log r base e over log 2 base e. So this is equation 3d. So we can use any of the equation to get our answer. Now don't forget here. Don't forget that here is 2. Now the last formula, that is formula, fourth formula is a direct formula. I call it direct formula, but it can solve all questions, especially when it is not giving us half-life really. So here we will say that n naught equals, we go down, here will be first t, n naught over 2 air. This is second half life. It becomes n naught over 4. We multiply by half again. Then we go further. We say third half life. It should now become n naught over 8. By the time we have the fourth half life, we have n naught over 16, and so on like that. This means that the number of the nth of t here will give us what? Will give us the n naught over 2 raised to power n. That is the meaning. That is remaining. The remaining part here is what we have here. So now the last thing that I want to get, all the second to the last, the fourth, the fifth formula here is that you see that NR is always, just like I said there, 1 over 2 of what? Over n naught, that is NR is equal to n naught over R from the formula I gave us initially. So we must note this. So if you find it well, you see that R equals n naught over R from what I've done, from what I've written here initially. You can see that I just replaced it. So then I told you that NR plus NB is equal to n naught. Let's now see the effect of ND. So from here we can easily see that our NR, the fraction is having this fraction of the remaining times n naught, which means that FR is equal to 1 over R. Shikeno, just for 2 raised to power n, just 1 over 2 raised to power n. So once you know what n is, that's the end. So this one, you must get it right, is equation 5a. Then the last one, as I was saying, that NR plus ND is n naught. So ND now is equal to n naught minus NR. That is ND, that decayed will give you n naught minus 1 n naught over R, which means that what we are saying here is that ND is equal to what? N naught in bracket 1 minus 1 all over R, which means that ND here is equal to n naught multiply, then find the LCM. 1 in R times 1, R minus this one is 1. So the formula we are getting here is what? 5b. So this is where the whole formula will end. Now let's go to examples so that we can be happy. I have a couple of examples here. So the first example here says that in 24 days, the radioactive isotope decreased in mass from 64 grams to 24 grams. What is the half-life of the radioactive material? So this one is quite easy. From what we are given here, we are dealing with number 1. Let me just pick it there. Pick it straight so that it be the one we are solving straight. Question 1 to be solved now. Paste, 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 paste. I don't like the way it's pasted here. well, not bold. That. Now, it says that in 24 days, a radioactive isotope decreased in mass from 64 grams to 2 grams, which means that we have T, they gave us total time taken 24 days. We're given N naught from 64 grams to, we're given NR as what? As 2 grams. We have to calculate the half-life. See, unknown. So this one is quite easy here. What we do here is to first find the number of what? This disintegration itself. How does it disintegrate? So we have N equals T over T. We don't know that one for sure. But we know the R equals N naught over NR, which is what? Which is 64 over 2, and that is what? 32. Now, R equals 2 raised to power N, which means 2 raised to power N equals what? 32. And from there, we have 2 raised to power N equals 2 raised to power 5. We change it to the same base. 32 is now 2 raised to power 5. So N equals what? 5. Take them down. What is this one? Is T over T, right? Equals 5. That is, we have 24 days over T equals 5. Cross multiply, T equals 24 days over 5. And the final answer is what? The final answer is going to be 4.8 days. Now, that is the first formula. Second formula that I call direct formula. Direct method. In this case, you now do it one by one. Is that okay? We have 64 grams. The first T gone, so we now have half of it left. That's 32 grams. Second T, second half-life goes, it will remain 16. Just be divided by 2. The third T, it now remains 8 grams. By the time we have the fourth half-life, we have 4 grams left. And now we have the fifth half-life. It remains 2 grams, which means that how many half-life do we have there? We have 5T in all. So, and they gave us the time. 5T equals 24 days. And that means T itself will be what? Will be 24 days. Divided by 5, which is same thing as 4.8 days. You can see that this thing is simple. Next thing here that I want to do is number 2 example. Number 2 example, let's pick it. Number 2 example is coming, is loading. Number 2 example. We can see this is, sorry about that. Let me just look at the question straight. This is 1997 number 52. It says that the half-life of a radioactive material is 6 hours. What quantity of 1 kilogram will decay in 24 hours? You can see that. See the question. Question is interesting. So here we want to solve the question. Let's see the solution to the question. It says that the half-life given half-life is 6 hours. What quantity of the kilogram of 1 kilogram of the material will decay in 24 hours? We are given the total time taken to be 24 hours. He now asks for, we are given the original number of atom to be 1 kilogram. He now asks for ND. ND or no. That is the number that will decay away. But all we know is what here? All we know is that N, small letter N, is the number of half-life here is 24/6, which is equal to 4. And we know R. R is R is 2 raised to power n, which is equal to 2 raised to power 4, and that's 16. Then ND, giving you the formula there, that is going to be what? N naught in brackets R minus 1 over R, and that will give you what? It will give you 1 kg times 16 minus 1 all over 16. So that will be 1 kg times 15/16. Then we can decide to find the answer. From here, if I subtract 0.0625 from it, from 1, it will give us 0.9375 kilogram. That's the final answer. Over 2. Just like that. Simple thing. Number 3 question. This is JAMB 1985, number 50. That one, let's solve it. Let's see. So here we have what here? They say that a radioactive sample initially contains n amount. Okay? From the question, n naught is equal to n. And they say that after 3 half-life, n equals 3. 3 half-life happens there. So, oh, sorry, before I go, I didn't use the other method. That other method needs to be used now so that you can be happy. So what's the other method that I said we use? That's the direct method that I said the other time. So here we have 1 kg. 1 kg. By the time we have the first 6 hours, we are left with 1 all over 2 kg. We have additional 6 hours. Second 6 hours. That remains 1 over 4 kg. We have third 6 hours. That will remain 1 over 8 kg. By the time we now have the fourth 6 hours, making 24 hours, we have 1 all over 16 kg. So this one is 6 hours. It will have amount to 12 hours here. Here it will amount to 18 hours. Then it gives us a total of 24 hours here. So that is what they say we should do. But what is remaining now? Remaining will be 1 kg minus 1 over 16 kg. If you do it well, you get 15 kg over 16. And that is the answer we got the other time. So here, let's look at it. They said a radioactive which sample which initially contain atoms after 3 half-life, the number of atoms that have disintegrated is dash. So in this one, quite easy. So the number that have disintegrated, that is NDA, is unknown. But from here we know that R is 2 raised to power n, which is 2 raised to power 8. So number that disintegrates here is quite easy to just say that is n naught times R minus 1 all over R. What we are saying here now is n, being n naught equals n here, into what? Oh, sorry, here is 2 raised to power 3, and that's 8. So that's 8 minus 1 over 8. The answer is 7n over 8. So the one that has been written away is 7 over 8. So let's see it again. So initially we have n, then first t give us n over 2, second t, we have left n over 4, just multiply by half. The third t, we have n over 8 by multiply by. So the remaining now, the remaining is n over 8, while the decay part is n minus n over 8. We do it well, we get 7n over 8. So then number 4 question. Number 4 question is coming. Number 4 question says that let's see. So number 4 question, that's 1992, number 49. It's like the same question they are asking, but let's see what they are saying. They said that after 3 half-lives, the fraction of the radioactive material that have decayed is dash. So we know that the decayed RD is equal to 7n over 8. So the fraction that decay, FD now, is just 7 over 8. That's the answer. So we don't need to solve anything since we have solved number 3. They are almost the same. So the fraction is what they ask. Just pick the fraction by the side of the something that you are there. This is a NECO question 2006, number 58. Question 2008, number 58, NECO. Now it says 2006, number 58. The half-life of a reactive element is 24 hours. So let's go there. The half-life T equals 24 hours. It is a whole day, that's the meaning. Calculate the fraction of real element that would have disintegrated. So almost the same question. In 96 hours. T equals 96 hours. So N equals T over T, which is 96 over 24. By so doing, let's divide. This will give you 4. So with this, they ask for FD. The question they ask for is FD, number that will have disintegrated, so or decayed. So from here, we have our R equals what? Equals 2 raised to power n, which is 2 raised to power 4, and that's equal to 16. Now, the decayed number ND is equal to N naught into brackets R1 minus 1 R minus R times over R. So that will give us what? Will give us, oh, they said the fraction. So we don't even need N naught. So it's the fraction that we need here. So okay, don't worry. Let me just leave it like that. N naught. So that means it is N naught times FD. And our FD here, that's N naught times our R here is 16 minus 1 over 16, which is N naught times 15 over 16. And the FD here is equal to 15 over 16, or we call it what I call that time 0.9375 is the fraction. But the same fraction, we don't need the decimal. Number 6. Oh, my time is almost gone now, but I need to solve many of these questions. Okay, now let's see this one. It says that it's also an echo question. Also an echo question. So this one is radioactive isotope has a life of 8 days. We have T equals 8 days. Then we have, they said, what fraction of the atom will remain after 72 days? So we have total time to be 72 days. N here is known to be T over T. 72 over what? Over 8. That's 9. R is 2 raised to power n. Oh, I didn't use other formula for all these things. 2 raised to power 9. And that will be 512. Yes, 512. Now, we have to calculate FR. No. But you know that, let me just write the formula out. NR is equal to 1 over R N naught. That I told you it is FR times N naught. Which means that FR itself is 1 over R. And our answer here is 1 all over 512. What that be in decimal, I don't know for now. Let me check my time. I need to stop this thing by I need to stop it now. So this is where we are going to stop for today. I believe you have really understood the topic very well. It remains some questions which I will leave it out like this. See the question. If you can solve the question is here. Solve the question. Number 7, number 8, and number 9. You can send it to the YouTube. You can send it to me on Telegram. If you are just new here, you can reach me out here on this Telegram here, which is https://t.me/pioneersmp, or you call me on this or WhatsApp me on this number straight ahead. You get me. So this is your Pioneer Maths and Physics class. See you when I see you, and bye for now.